Hello, welcome to the lecture notes on applications of systems. I will set these up and I will work some of them out and I will give you the solutions to all of them. The first thing I want to point out on number 1 is I've highlighted 6,106. Be sure that your worksheet has that amount. A glass blowing studio gives 3-hour and 5-hour classes for $43 an hour. If the studio has collected $6,106 for a total of 34 classes, how many 3-hour classes and how many 5-hour classes were paid for? So first we should define our variables. Let X equal the number of 3-hour classes So 3 times 43 would be $129 total. Let Y equal the number of 5-hour classes. And a 5-hour class would cost $215, 5 times 43. So we're going to have two equations. We know that there were a total of 34 classes. So the number of 3-hour plus the number of 5-hour have to equal the number of total classes. And the second equation will be our money. 129 times X plus 215Y equals $6,106. So those are your two equations and two unknowns. I will go ahead and solve this one by elimination. You could use substitution as well. But if I multiply the first equation by negative 129, I will eliminate X. So Y is equal to 20. But we need to solve for X as well. And we know that X plus Y is equal to 34. X plus 20 is equal to 34. So X is equal to 14. So we need to state the answer. The answer would be, we have 14 3-hour classes and 20 5-hour classes. And there you have it. Number 2, during a strenuous exercise, an athlete can burn 9 calories per minute on a stationary bike. I think we need to fix the word stationary there. And 11.5 calories per minute on a stair climber. In a 30-minute workout, an athlete burns 300 calories. How many minutes does the athlete spend on each type of exercise equipment? All right, so the question is, how many minutes does the athlete spend on each type of equipment? So that's going to give you a hint on what your variables will be. We can let X represent the time on the bike. And Y can be the time on the stairs. we know that in a 30-minute workout, so the time on the bike plus the time on the stairs is equal to 30 minutes, that you burn 9 calories per minute on the bike and 11.5 calories per minute on the stair climber for a total of 300 calories. There are your two equations and your two unknowns. You can solve by substitution or elimination. But the answer will be 18 minutes on the bike and 12 minutes on the stair climber. Number 3, a total of $5,000 is invested in 3% and 5% annual interest. After 1 year, the total interest equals $210. How much money is invested at each interest rate? So the question helps you define your variables. So we'll let X equal the money at 3%, and Y can equal the money at 5%. We know that we invested a total amount of money of $5,000, and we're going to take the interest rate times the amount of money invested in it plus the interest rate times the amount of money invested at that interest rate, and the interest plus interest has to equal total interest. Again, you can solve this by substitution or elimination. We will invest $2,000 at 3% interest rate and $3,000 at 5% interest rate. Number 4, at a softball tournament, tickets for 2 adults and 5 students cost $47. Tickets for 3 adults and 8 students cost $74. Determine the price of an adult ticket and the price of a student ticket. So let's let X be the price of the adult ticket. And Y will equal the price of a student ticket. So your two sentences are your two equations. Tickets for 2 adult and 5 students cost $47. Tickets for 3 adult and 8 students cost $74. So 2x plus 5y equals 47, and 3x plus 8y equals 74. I'm going to go ahead and work this one out. I'm going to use elimination. I'm going to multiply the first equation by -3, the second equation by 2. I'll add the equations together. We'll eliminate x. we have y is equal to 7. And now to solve for x, we need to substitute it in one of the original equations. I'm going to go ahead and substitute it in the first one. So x is equal to 6. So our answer, $6 is the price of the adult ticket. And $7 is the price of the student ticket. Number 5, a chemist has 20% and 50% solutions of acid available. How many liters of each solution should be mixed to obtain 10 liters of a 40% acid solution? All right, I choose to set these up as if I were a bartender, and I'm mixing 2 alcoholic beverages together. So I call this the bucket method. So I have 2 buckets. I'm going to add them together, and they are going to equal the mixture down below. So a chemist has 20% solution and 50% solution. How many liters of each should be mixed? So how many liters of 20%? How many liters of 50% should be mixed to obtain a 40% mixture, and we need 10 liters. So my 2 equations, I need the amount. So x plus y is equal to 10. And then I'm going to multiply 20% of x plus 50% of y is going to equal 40% of 10. And I set all of these mixture problems up this way. These are very similar to the problems in my math lab where they will use a table. Either way is fine. We'll get the same answer. I'm going to go ahead and work this one out, and I'm going to use substitution. I'm going to solve the first equation for y. So y is going to equal 10 minus x. And I'm going to substitute 10 minus x in the second equation for y. And because 20% is the same as 0.2, and I'm going to solve this for x. So x is equal to 3 1/3. So what does this mean in terms of the context of the problem? X is equal to 3 1/3 liters of 20% acid solution. We can solve for y. X plus y equals 10. So that's going to be 6 2/3 liters of 50% acid solution. All right, let's try another one. A lab tech needs to make an 18-liter batch of 40% acid solution. How can the laboratory technician combine a batch of an acid solution that is pure acid with another that is 10% to get the desired concentration. Again, I like to think I'm mixing 2 drinks, 2 buckets. I'm going to add those 2 mixtures together to get what I need. The lab tech needs to make 18 liters. So that's my amount, 18 liters of 40%. The laboratory technician has pure acid, which is 100%, and 100% is 1, and another solution that is 10%. How much of each do we need to mix together? So again, we have our amount in terms of liters. X plus Y has to equal 18. And pure acid plus 10% has to equal 40% of 18. You can solve this one by substitution or elimination, but the answers will be 6 liters of pure acid and 12 liters of 10% acid solution. Number 7. Bird seed costs 67 cents a pound. Sunflower seeds cost 97 cents a pound. Jen's Bird Store wishes to make a 30-pound mixture of bird seed and sunflower seeds that sell for 89 cents per pound. How many pounds of each types of seed should she use? So let's let X equal bird seed. And let's let Y equal sunflowers. So we have a bird seed costs 67 cents a pound. Sunflower seeds cost 97 cents a pound. She wants to make a 30-pound mixture that sells for 89 cents a pound. How much bird seed? How much sunflower do we need? So we have X plus Y equals 30, and 67 cents times the bird seed, 97 cents times the sunflower will equal 89 cents times 30 pounds. Again, you can use substitution or elimination, but the answer would be 8 pounds of bird seed and 22 pounds of sunflower seeds. Number 8, cornmeal is 6% protein. Soybean is 10% protein. How many pounds of each should be mixed together in order to get 240 pound, guess we only need one of those pounds, mixture that is 8% protein? So I'm going to set this up using buckets. So we have 6% protein and 10% soybean. How many pounds of each should be mixed in order to get 240 pounds? That is 8% protein. X plus Y is equal to 240. 6% of X plus 10% of Y will equal 8% of 240. Again, use substitution or elimination. And the answer will be 120 pounds of 6% protein and 120 pounds of 8% protein. That would be 10% protein. Number 9. Nancy works at Nancy's Dairy Farm. She wishes to mix whole milk, which is 3.25% fat, and skim milk, which has no fat, to obtain 715 gallons of a mixture of milk that contains 1% fat. How many gallons of whole milk, how many gallons of skim milk should Nancy mix to obtain the desired mixture? So we are going to mix whole milk, which is 3.25%, written as a decimal is 0.0325, with skim milk, which has no fat, to obtain 715 gallons of milk that contains 1% fat. So we have X plus Y is equal to 715. So this one's a little easier to solve because we can immediately solve for X. Because we have 0Y. So X is equal to 220. And we can find Y because we know X plus Y has to equal 715. So we'll write out the answer. We need 220 gallons of 3.25% fat. And we need 495 gallons of skim milk. Number 10. Chip is on a strict diet, a strict dog diet. Chip is to receive 56 grams of protein and 8 grams of carbohydrates. Jin, his owner, only has 2 food mixes available of the following compositions. How many grams of each mix should be used to obtain the right diet for Chip? So let's change these percents to decimals. So we need an equation for protein. So the protein is mix A, and we have mix A and mix B. So we need 0.5A plus 0.4B has got to equal the total protein. He is to receive 56 grams of protein. Then we need an equation for the carbohydrates. So we have 8% mixture A plus 4% of mixture B, and he needs 8 grams. So here are your 2 equations and your 2 unknowns. You can use substitution or elimination. And the answer, Chip needs 80 grams of mix A and 40 grams of mixture or mix B. And finally, number 11. A 15-pound mixture of coffee that contains both decaffeinated and regular coffee costs $53. The decaffeinated coffee costs $3 per pound, and the regular coffee costs $4 per pound. Write and solve a system of equations that gives the amount of each type of coffee in the mixture. So we have 2 kinds of coffee. I will let X be the decaf and Y be the regular. We know that we need 15 pounds total. So X plus Y equals 15. And we know that it's $3 per pound for decaffeinated. So 3X plus regular coffee is $4 per pound. So 4 times Y is equal to 53. Again, solve by substitution or elimination. And the answers are 7 pounds of decaf and 8 pounds of regular. That's all we have. Good luck. If you have any questions on how to work these out, be sure to ask your instructor. Bye for now.